Welcome at the third part of lesson number 1. So we continue with the dunnage, in Dutch garneringsmateriaal. Something to be aware of, we distinguish between planks, beams and wedges. In Dutch it's planken, balken and keggen. So in this example, as visualized, you see two beams placed at the tank top, and try to figure out um, uh, when we install a dunnage, we need to have attention for the stiffenings in the double bottom. Nevertheless, we also need to look at the wood grain of the dunnage, in this case the beams. Bear in mind when you look at these pictures, which one is the safest. So we're gonna put some weight on top of these two beams, and in which case is your option the most safe. Put it on pause, otherwise if you need some more time, the answer is this one. The one on the left, there's no risk of vertical splicing because the wood is able to compress a bit. On the right side, where it's mentioned risk of vertical splicing, if we have an uneven weight distribution, for what kind of reason, there's a small risk of splicing the wood. In the case where the wood splices, the stability of the cargo may change, and maybe the cargo can move a bit, and that's risky because lashings will not be tight anymore, most likely. So be aware of the wood grain and put it in the right way, and that's the one on the left. So some things to consider before we sign a contract, but also in practice when the ship receives the voyage orders. You need to calculate how much cargo can be shipped in a ship. There's not only the restriction of the volume of the cargo hold, but there are some others. But what you need for information, stowage factor or the specific weight, or soortelijk gewicht in Dutch, the cargo hold volume, the capacity. If we have multiple discharge ports, you need to be aware of remaining cargo in the hold, how much capacity is already taken, how much is left for the cargo to be calculated. At the draught mark corresponding with the maximum displacement of the ship. As we've seen in ship knowledge, the ship is not allowed to be overloaded, and you need to be 24/7 comply with the freeboard load line rules, and you need to anticipate on your voyage with that as well. The maximum load of tank top, twin decks or hatches, something to be aware of, otherwise you damage one of the three. We don't like it, and we don't like it because you might not be seaworthy or cargo worthy, or both, anymore. The daily consumption of fuel oil, heavy fuel oil, fresh water, it's something to be aware of when you calculate how much we're gonna take with us this voyage. The chart of seasonal areas and zones. I didn't translate it in English, but I will show you it later on. And in case we have more than one discharge port, you need to be aware of the setup of the twin decks and the discharge sequence. So in Dutch it means the los volgorde. You need to be aware of it when you design as a chief officer where you put which cargo where in the cargo hold. Usually we have the principle first in, last out. If you use this principle, it will most likely prevent that as a ship you need to shift cargo to discharge other cargo. Shifting cargo during loading or discharging, it's taking time and energy and should be prevented. So here the chart of seasons and zones, as mentioned earlier on with ship knowledge, during the sea voyage, um, the ship at all times needs to comply with the low line rules concerning the minimum freeboard. And for these rules, there are zones among the world, and it's based on risk assessment. Um, so this is done by naval architects and meteorologists of the IMO. They decide and yeah, they have some history about the weather. And they think about the risk a ship can undergo during a sea voyage in a certain zone. For example, here in the tropical area, they allow you to have a bit more wind, uh, or not so often as in summer period. So you can take a bit more cargo with you in that zone. I hope you a little bit understand that underneath this layout, there's a risk assessment done by meteorologists and naval architects. So it's obligatory to remain seaworthy, and you need to have sufficient freeboard during the sea voyage at all time. We're gonna use this chart you just saw for calculations later on, and then you will most likely get a better grasp out of it. Cargo hold capacity, we have some parameters we use for writing down stuff. If we use bale space, we use it for project cargo, and the broken stowage is already included. If we use grain space, I hope you can imagine that grain, the particles are so small that there's no broken stowage basically left. There's all the space is taken by grain parts because they are so small. That's why we have about zero broken stowage. Usually we need to keep a little bit of ullage between the top side of the grain and the lowest part of the hatches for some surface ventilation. But if we speak about grain space, we usually mean the full space, the full volume of the hold or the space. Oil space, it's the same, but it's for fluids. It takes a bit more than grain space, slightly. So to make a preliminary stowage plan for local stuurplan, some rules of thumb. Uh, Heavy cargo we prefer to place close to the keel of the ship, for example on the tank top. That's the first option we have if we start from bottom to up. Close to the keel, so it's on the tank top. And the tank top is also, because of that reason, is designed to have more weights on top of itself compared to twin decks or hatches. There's more stiffenings in the double bottom tanks, so the tank top is more strong. Don't load on top of fragile cargo. Makes sense if we already have something from glass on our tank top. We don't put any steel on top because the risk of breaking the glass underneath is too high. Same applies to wet cargo. There can be a leakage later on during the sea voyage, and then the dry cargo gets wet. So we put the wet cargo always on a low place, preferably on the tank top, because of that reason. Then the fluids can drain off to the bilge wells, and then we get an alarm, but we don't damage any other dry cargo by doing that. The bulk cargoes, we keep certain grades separate with a vertical placed bulkhead. This bulkhead, often we use twin decks, but we position them vertically instead of horizontally. And by that, we can separate different grades. And with grades, we mean different kind of cargoes, basically. bulk cargoes. So maybe the Aldi has a cheaper grain than Albert Heijn, but it's shipped in one ship, but we need to keep them separate by using vertically placed bulkheads. No flammable cargo next to the engine room bulkhead. In case something goes wrong in the engine room, there's going to be heat transport via the bulkhead to the cargo, and that's the reason why we don't want any flammable cargo next to this bulkhead, because the flammable cargo can ignite as well, or the risk is going to be higher if we put that cargo close to this bulkhead. Any dangerous goods, we need to separate them according to a code made by the IMO, and that's the IMDG code. We're going to speak about it later on, and we're going to do something with it during the stowage plan exercise we have during this block. En be aware of the stack height, stapelhoogte in het Nederlands. Be aware of the stack height. So here we have steel pipes, four layers, 4 tiers. We don't only think about where we can put this total weight on the ship, but we also need to think, can tier number 1 have the weight of tier number 2, 3, and 4 on top of tier number 1? That's something to keep in mind. So also here we need to know if the total weight can be on this stack, but also if tier number 1 can have the weight of tier number 2 and 3 on top of tier number 1. So this is a special kind of lashing. We call it pyramid stowage because it has the shape of a pyramid, triangular, and the angle doesn't get any sharp over here. And yeah, with something which is round, this is the best way to stow any round cargo on a vessel. Pyramid stowage. So make blocks of cargo, and usually these blocks are squared, especially with these book-shaped cargo holds. Don't waste too much ullage on the top side of any block, but in case you need to ventilate, keep enough space, keep enough ullage to make sure that the air can flow around the cargo. So here's a vessel with some amount of blocks of cargo. This yellow stuff is its grain, and here steel pipes. We also need to be aware of the SOLAS line of sights. So the bridge watchkeeper, one of the navigational officers, they need to have a certain amount of view in front of the ship, like the angle. It cannot be too big, and you need to be aware of it when you make your stowage plan. Funny thing is the program we use, this block, it's giving an alarm when you exceed the SOLAS line of sight rules. As you can imagine, all the blocks we've put on this ship, they all have a certain center of gravity, and they have it in 3 degrees of freedom, and all 3 they are important to you when you make a stowage plan. So we start with the first 2. We keep number 3 for the next lesson. If we speak about the ship and we compare the ship with the blocks we just saw, all the weights on the ship, including the ship itself, they all have a center of gravity, and they have 3 degrees of freedom. And here we see 2, longitudinal and taken from the keel vertically. Longitudinally, it's taken from the rudder stock, in Dutch de roerkoning. Usually it's where they design frame number 0, spant 0, die loopt hier doorgaans. And the vertical center of gravity, it's taken from the keel. And by having all these centers of gravities, we can start calculating where gonna be the center of gravities from the combined ship with the cargoes after loading. And in the old days, it's done by hand. Now we use stability programs or Excel. During the lessons, we do a little bit by hand, but quickly we're gonna change to Excel. It's nice to master Excel for these lessons, also for scheepswerktuigkunde, because it saves you a lot of hassle. And the benefits of Excel is if you make a small mistake, it's easy to correct the small mistake and not change the rest of the calculation. If you do it by hand, it's a lot of writing extra. So what we have here, we have the ship with a certain center of gravity vertically from the keel, and we put cargo also with a certain vertical center of gravity from the keel. I hope you can see that the VCG of the ship is smaller than the one of the cargo. But now we have loaded, we want to know the new vertical center of gravity of the new combination. So the ship plus the cargo. And we make sorry, I don't know the English word, momentenstelling in Dutch. And we can calculate the new weight of the ship, the displacement, but also the new center of gravity. So we're going to practice this a bit more in the class. I hope you get a little grasp of it by seeing this now. If you didn't, don't feel bad because we're going to exercise this a lot. So now we know a little bit about this momentenstelling. The same is actually done in the ship stability program with all the tanks on board. So bear in mind, if you arrive in a new port with a multi-purpose ship, you're prone to take new cargo in. After arrival of the vessel, when the ship is safely moored, usually the captain calls the chief engineer and he says, "We're finished with the engine," and it will be written down in the boat logs, in the journals, the engine room journal and the one on the bridge, with the same time, hopefully. Uh, after after that, the chief engineer is going to stop the main engine, and somebody will sound all the relevant tanks and make a new remaining on board list for the chief officer. And the reason is, in the stability program, all the tank data needs to be updated. The weights need to be corrected. And that we do with this remaining on board list. So that's it. See you later. Thanks for watching.